Good evening, students. Uh, Today we will discuss properties of addition and subtractions of integers, uh, closure under addition and closure under subtractions, then commutative property, associative property, and additive identity. All right, we'll discuss today. See, um, properties of addition and subtraction of integers. This is the heading. Number one, first property is closure under addition, right? Closure under additions. Hmm. And number two property is closure under subtraction, right? Hmm. Okay, first, uh, let me discuss first these two: closure under addition and closure under subtraction, right? Now, what it says: closure under addition and closure under subtractions. These two properties says that when we added or subtracted, any two integers, the result will also be an integer, right? These two properties says, okay, all right. These two property, these two property says when we added or subtracted, right? When we added or subtracted any two integers, hmm, the result the result the result or resultant will also be an integer, right? When we added or subtracted any two integers, the resultant or result will also be an integer. Hmm. See, let me give an example. Example number one. Okay, for number one, closure under additions. So when we suppose I add two integers, 2 plus 7, suppose 2 plus 7. 2 plus 7 is 2 plus 7. When we add, we get 9. So this 9 is also an integer, isn't it? 2 is integer, 7 is also integer. So when I added two integer plus integer, okay, 2 is integer plus 7 is also an integer. So when I added two integers, I also get an integer, right? This 9 is also an integer. Suppose 5 plus 6, 5 5 is integer, 6 also is 6 also integer, integer plus integer. 5 is integer, 6 also integer. 5 plus 6, 11. So this 11 is also an integer. Okay, closure under additions. It says when we add any two integers, the resultant or result is also an integer. Now to closure under subtraction. Okay, now when I subtract any two integers, the results also is the result will also be an integer. Suppose 5 minus 6. 5 minus 6. The sign of 5 is 5 plus minus a minus 6 minus 5 1. 6 is greater than 5, the sign of 6 is minus, so we take minus. Bigger number sign we will take. So now see, 5 is an integer, 6 is also integer. So when I subtract these two integers, the result I got 1 is also the result I got is minus 1. Minus 1 is also an integer. Okay, integer. Actually, integer we denote by z. Okay, z, this z, not I. Capital letter z. Okay, capital letter z. Z minus z, we also get z. Another example, suppose 15 minus 6. 15 minus 6. 15 minus 6 is what? 9. So 9 is also integer, isn't it? 9 is also integer. So these two properties says that these two properties, closure under addition and closure under subtraction, it says that when we added or subtracted any two integers, the resultant will also be an integer. Okay, now we'll move to next, third property. Third property says that third property is what? Commutative property. Commutative property. Let me show you this this one, commutative property. Okay, now see, commutative property. Right, commutative. The word commutative means, it means rearrangement. Okay, rearrangement. I have already discussed this property in my previous video. Please go through my previous video. Alright, the word commutative means rearrangement. It says, this property says that okay, suppose I write any two integers, a plus b. This a plus b, we can also write b plus a. Just we can simply arrange. Okay, just simply we can arrange the numbers. Right. Suppose 5 plus 6. 5 plus 6 we can also write. We can 5 this 5 plus 6 we can also write 6 plus 5. See, 5 plus 6 is 11, and 6 plus 5 is also an 11. Okay, so this commutative property, it says that we can edit the numbers in any order. Okay, we can change the numbers in any order. We can uh, edit the numbers in any order in case of commutative property. See for let's see for another example. Let's see another example. Suppose 7 plus 6. 7 plus 6, we can also write 6 plus 7. The result is also same. 7 plus 6 is 13. 6 plus 7 is what? 13, isn't it? So just rearrangement. Commutative payments, just rearrangement. Now let's move to our next property. That is number 4, associative property. Associative property. see, commutative property, what does it says? It says that we can arrange the number in any order in case of additions, right? In case of additions, we can write the numbers in any order in case of additions. Now see, uh, associative property. Associated, the word associative means, the word associative means grouping. Okay, grouping. The word associative means what? Grouping. It is already explained in your textbook. You can go through it. Now see, if I suppose uh, associative property means grouping the integers. It says that we can group the integers. Okay, see, let's suppose I write a plus b plus c. Hmm. A plus b plus c. I want to write b plus c together. This equals to, now if I wish to write a plus b together and plus c separately, this is also correct. Okay, we can also write in this manner. Now see, example I'm taking. Example, suppose in integers I write a value a equal to 2, then b value equal to 3, c value equal to 5. Suppose now suppose a is what, 2. Put the value here, a is what, 2, plus b value is what, 3, plus c value is what, 5. What do we get? 2, 3 plus 5, 3 plus 5 is what, 8, 2 plus 8 is what, 10. We get 10. Now here also put a value here. This is left hand side, this is right hand side. A is what, 2. Put here a is what, 2, b is what, 3 bracket, plus c is what, 5. Taking ab together. Okay, 2 plus 3. Okay, right, first 2 plus 3 is what, 5, then plus 5, 5 plus 5, 10. Similar, see, we get the same answer. So associative property says grouping the integers. We can group the integers. Okay, we can group the integers. Number 5, we have the last property, that is additive identity. Additive additive identity, right? uh, it is given in your textbook. You can go through it if you want. When we add 0 to any whole number, we get the same whole number. 0 is additive identity for whole numbers. See, when I add when I add or subtract any integers with 0, we get the same number. Okay, this property said that when I add or subtract with any integers, when I add, I mean, when I add or subtract any integers with 0, then I get the same result. See, when we add or subtract, okay, when we add or subtract integers, any integers with 0, we get the number itself. Okay, you get the number itself. Say for example, 2 plus 0. What do you get? 2 plus 0, 2. same number I'm getting. Now 2 minus 0, what do you get? 2. So when I add integers with 0, I get the same result, 2, the number itself. And when I subtract 2 with 0, I get the same result, 2. Okay, so when we add or subtract any integers with 0, we get the same, we get the number itself. Suppose suppose minus 2 plus 0, minus 2 minus 2, and minus 2 minus 0, minus 2, same, right? Different examples you can give. Suppose 5, 5 plus 0, the number itself, 5. Okay, now 5 minus 0, 5, same. Okay, so so let us recall what we have discussed today. Properties of addition and subtraction of integers. Firstly, we have covered these two: closure under additions, closure under subtractions. So these two properties says that when we added or subtracted any integers, the resultant will also be an integer. Example: 2 plus 7 equal to 9. 2 is integer, plus 7 is also integer. So when I add two integers, the result I got 9 is also an integer. 5 plus 6 is what? 11. Integer plus integer is also an integer. Okay, integer plus integer is also an integer. Integer plus integer is also an integer. This is a concept. Now when I subtract 5 minus 6 minus 1, minus 1 is also integer. 15 minus 6, 15 minus 6 is what? 9. 9 is also integer. So these two properties says that closure under addition and closure under subtraction, when we added or subtracted any two integers, the resultant will also be an integer. And commutative property says that uh, we can write the uh, integers in any order. Okay, any order, a plus b, we can write b plus a. Okay, in the case of, this is in the case of addition, commutative property under addition. Okay, this in the case of commutative, we can write the integers in any order under addition. Alright, and the word commutative means rearrangement. See here, a plus b, we can also write b plus a. Same, 5 plus 6, we can also write 6 plus 5. Okay, 5 plus 6 is what? 11. 6 by 6 plus 5 is what? Also 11. Same meaning. I can also write 7 plus 8, 7 plus what? 18. I can also write 8 plus 7. Oh, 7 plus 8 is what? 15. And 8 plus 7 is what? Also 15. Okay, we can change the order. The commutative property says that we can change the order. We can write the integers in any order. Okay, and associated property, grouping of integers. This property says that we can grouping the integers. A plus b plus c is also equal to a plus b plus c. Okay, now giving example: a equal to 2, b equal to 3, c equal to 5. So putting this value in this equations: a equal to what? 2, b equal to what? 3, c equal to 5. Okay, now 2, 3 plus 5 is 8, 2 plus 8 is 10. Now here a, 2, b, 3 together, 3 plus 5 is what? 2 plus 3 is what? 5. 5, 5 plus 5 is what? 10. Okay, now additive identity. When this property says that when we add or subtract any integers with 0, we get the number itself. Okay, we get the number itself. 2 plus 0 is what? 2, the number itself. 2 minus 0 is what? 2. Minus 2 plus 0 is what? Minus 2. minus 2 minus 0 minus 2 same. When we add or subtract any integers, we get the number itself. 5 plus 0 is equal to 5. 5 minus 0 is also 5. Okay. So today we have discussed closer properties of addition and subtraction of integers. Okay. Next, in my next video, we will try to solve question number 4.